we kind of go through phases as a society where we swing between the two poles of worrying about how much energy our buildings are using and worrying about um, what's floating around our indoor environments, really. And they're kind of diametrically opposed. Of course, you can crank up the ventilation as much as you want. You can do a lot of air cleaning, but you have to pay for that.
Welcome to the Construction Disruption Podcast, where in just about 30 minutes per week, we uncover the future of building and remodeling. Join us as we explore an industry that is constantly evolving with new products, new practices, and new technologies. From builders to remodelers to executives, as well as those with outside perspectives too. Each episode of Construction Disruption, our goal is to meet with forward thinkers who will share their unique insights. Construction Disruption is sponsored and created by Isaiah Industries, a manufacturer of unique metal roofing systems and other building materials. I'm Todd Miller with Isaiah Industries, and today our co-host is Seth Heckeman, our sales manager, and our producer here behind the scenes is Ryan Bell. Seth, how's your day going?
Going well, Todd. Thanks so much for connecting with and inviting Dr. Jordan Clark, our guest here today, for our conversation. Really looking forward to it. Most episodes, you start off kicking me a question, so I thought we'd turn the tables and ask you one here to begin. So a question I came up with was, over your 40 years in the industry, we're really developing this podcast out of a response of, over your career, seeing our industry, construction as a whole, being pretty slow to adopt change, slow to innovate, slow to push for advancements. Why do you think that is, and how do you see that changing moving forward?
Oh my goodness, you couldn't give the old man a softball question, could you? Okay. I think it's interesting. As I look back at change and development I have seen in construction over the years, a lot of it that I have seen, at least, and I'm sure this varies from segment of the industry to segment of the industry, but a lot of it has actually come from military and aerospace technology that has then been adapted for private use and commercialization. For some reason, we don't seem to be seeing that kind of things come out of military and aerospace and making their way into construction the way that we once did. Maybe I'm just not enough in the know to see it, but I don't feel like I am. I think what really is going to drive significant change is the sharp young minds that are out there today, such as you and so many others, and our guests today and other guests that we're having. I think, what's happening is we got a lot of sharp young minds out there looking and saying, okay, what areas of our world haven't been changing much? And what are the things going on today that could drive change? So, of course, today we're dealing with things like increasing amounts of extreme weather. We're dealing with the whole quest for renewable energy, the quest for energy efficiency. Even just here in the last year, now we're dealing with people simply staying at home a lot more too, and people working from home. So that's kind of changing our approach to buildings and the structures that we live and the structures that we work in. The whole labor shortage out there, I think, is going to continue to drive the need for change. You're always going to have design trends. Our country is looking more and more at our raw material resources and realizing that we don't necessarily have endless supplies of everything out there. And so that's becoming a bit of a question. I think another thing I'm seeing a lot that I think is, those bright young minds out there who are striving for, these real changes in our industry, is the chemical red list that, we hear a lot about. And these chemicals that coming up down the road, we're going to see increasing amounts of regulation on using those chemicals. So that's going to force us also, I think, to look for change. And of course, we've got our guests today and so many great universities and building science departments across the country. They're doing lots of research. And I think we're going to see more and more commercialization of their ideas as well. So I guess my point is that I think maybe those change in development impetuses and those creative ideas may come from different places going forward than where I maybe saw them over the last 30 years coming from. But I still think they're going to come. There's enough driving factors out there that are going to make it economically viable for people to reach for new things. And, of course, whenever anyone comes with good ideas, then they got to figure out the way, can they get it funded? Can they be able to carry it off and create something that's scalable and sustainable? But, that's certainly the challenge with any business and any idea. So that's my answer.
Very good. Thank you.
So I'm going to segue into our guest today on construction disruption is Dr. Jordan Clark. As we look at the future of construction, I think it's really important for us to talk about what's going on in terms of building science research at leading universities. We chose Dr. Clark as our guest today. Well, partly because he does hail from our great state, and he is from the Ohio State University. But I also love the fact that he sort of leads the way in a couple of subjects that I know I personally have come to care a lot about during my time in the industry, and those are sustainability and also the health of the buildings that we live and work in. So how do we make sure that the buildings we live and work in are going to last? And also, how do we make sure that they're not going to make us sick with unhealthy air or other dangerous environments? So Dr. Clark received his PhD in civil architectural and environmental engineering and also a master's in architectural engineering from the University of Texas at Austin, where he was a member of the Building Energy and Environments Research Group. He has bachelor's degrees in civil engineering and philosophy from Stevens Institute of Technology. And before starting at Ohio State University, Dr. Clark held appointments at both the National Renewable Energy Laboratory and the Lawrence Berkley National Laboratory. Dr. Clark holds a dual appointment in the College of Engineering at Ohio State. He has a majority appointment in the Department of Civil, Environmental, and Geodetic Engineering and a minority appointment in the Construction Services Management Program. He's also a core faculty of the Sustainability Institute at Ohio State, which is an interdisciplinary collaboration aimed at answering the challenges of a quickly changing world. And he has PhD advising status in the Department of Mechanical and Aerospace Engineering and the Environmental Sciences graduate program. So there's no one better than our guest today to speak at what's going on out there with those that are up and coming in our industry. So certainly a very impressive pedigree, Dr. Clark. Again, thank you very much for joining us today. We sure appreciate your time, and I know that our listeners are going to enjoy your insight into the leading edge of building science. I'm kind of curious, what fueled your interest in this field? Were there particular life experiences maybe you had growing up, but what made you really care and become passionate about construction and building science?
Yeah, so I actually started out life right after undergrad as a structural engineer. I was working in Manhattan on underground tunnels, sizing rebar for the most part, most
Wow.
of the day. And that was great, but I sensed, as we all did, that there was going to be a big revolution in the energy world. It was just time, and everybody was investing a lot of energy, no pun intended, and investing a lot of money into kind of solving this climate problem, and I kind of wanted to be part of it. And I looked around like what can I do? I'm a structural engineer here. I kind of want to transition a little bit. I knew a little bit about how buildings came together, and read a lot about building energy efficiency being, the low-hanging fruit. Really, this is where we can make the biggest change before finding a different way to generate power. If we just figure out a way to kind of reduce the amount of energy that we need, that's the easiest way to kind of attack things in the near future, at least.
Right.
So I went back to grad school at the University of Texas. To do that, luckily, I got into that program. It was top one or two in the country at the time, at the architectural engineering program at Texas. And the rest is history. Yeah, I got to be part of this big change that's going on in our country and across the world right now.
Wow, good stuff. I know you look a lot and have worked a lot with indoor air quality. What are the things that have made that more of a concern in the past, or driven that to be more at the forefront of thought and concern than it used to be? I mean, we didn't even think about it when I was growing up. So,
Yeah, that's absolutely true. Yeah, I just gave a talk on this about a month ago. I think you may have heard that actually, where we kind of go through phases as a society where we swing between the two poles of worrying about how much energy our buildings are using and worrying about um, what's floating around our indoor environments, really. And they're kind of diametrically opposed. Of course, you can crank up the ventilation as much as you want. You can do a lot of air cleaning, but you have to pay for that, right? You have to pay for the conditioning of the air that you bring in. You have to dehumidify it and cool it down in the summertime. In the wintertime, you have to heat it back up so it's comfortable. So depending on what we're worried about at the time, we've changed the ventilation rates that are required, and mostly in commercial buildings we're talking about it right now over time. So for example, we had a bit of an energy crisis in the 70s. Ventilation rates required by law went way down. And then in the 80s, of course, what happened, we had this big rash of sick building syndrome in our commercial buildings. And we said, we don't know exactly what's going on here, but we better crank those ventilation rates back up. And then it switched back a little bit again with the big investment beginning in 90s, 2000s, where we're starting to worry about energy again. So we're starting to maybe not turn our ventilation rates all the way down, but think about better ways of controlling indoor air quality. And then the pandemic happened, right? So now everybody's thinking about what's floating around their air in their homes and in their offices. So those are the kind of things that kind of motivate societies to kind of move one way or another with regards to the energy indoor air quality spectrum, you might say.
wow, that's pretty neat. I never really thought about how those sort of things can create those trends and those ongoing changes.
Yeah, it's that pendulum swinging principle that we see so often in so many different things. But I'm curious, back in the 80s when there was, it got on everyone's radar, indoor air quality, post first energy crisis, pre second energy, focus. 80s, you said that, we were realizing our buildings were unhealthy. Can you go a little bit more into what the symptoms were, how that got on our radar then?
Sure. So this phenomenon of sick building syndrome, it's still not very well understood, but we do know that it's correlated to the ventilation rate per person. So if you turn down ventilation rate, consistently these things start showing up. Fatigue, upper respiratory symptoms, absenteeism among students and among workers. People are calling out sick more often. A decrease in productivity by the same workers, and there's even some evidence for some mental health issues. And the exact mechanistic understanding is still not developed, but we do know that it's strongly correlated to the ventilation rate. Yeah.
Interesting. Well, I'm glad people were thinking about those things or starting to become aware of in the 80s. I was mainly thinking about how to grow my mullet, but that was just my deal back then. So as you look at, things that are being done different to address air quality in buildings, is there anything that you think is going to be standard parts of construction in the future that, we're maybe are just now starting to think about?
Yeah. So, for example, the state of California 2 years ago made sweeping changes in their building codes. As of last year, the worst home that you could build in the state of California only used as much energy as you could produce on the roof. So it's net zero ready, right?
Right.
That's a huge change, right? So we're talking about things like air sealing, better insulation, state-of-the-art equipment, of course. but that's a sea change. If we're mandating net zero buildings, which is easier to do in California, of course, because of the climate and things, but that might very well find its way into the interior of the country in the near future.
Interesting.
So that's one thing. As far as the indoor air quality problem, dedicated ventilation has actually been required by the ASHRAE standard. If you're familiar with that, the American Society of Heating, Refrigeration, and Air Conditioning Engineers
Sure.
creates a ventilation standard, air quality control standard that's adopted by a lot of municipalities, either in whole or part of it's adopted. But they've actually required dedicated ventilation systems in residences for more than 10 years. A lot of municipalities have not yet adopted that, but I think you will see that, especially after COVID and everything. People are thinking about indoor air quality more. So that'll be a big change because the vast majority of our homes, especially if they're not kind of high end, you're well aware, don't have any dedicated ventilation system at all. Just rely on infiltration, kind of accidental air exchange between indoor and outdoor environments. And if we're in order to get to the energy goals, we need to tighten these up so there isn't as much infiltration. We're not conditioning air that's just been leaking into our backyard. And if we do that, of course, we have to provide some kind of smarter ventilation that we control. So the mantra is build tight and then ventilate right. So we're controlling what goes in and out of our building. So those are some big changes that I think we'll see in the near future.
Interesting. You mentioned in passing that meeting some of these energy goals are a lot easier in some climates than others. Do you think the technology is here and ready for middle America to be meeting those same energy standards that California has been pushing?
Oh, so I don't think it's just a matter of what technologies are better suited to different climates. So I've talked with a lot of people about this. Ohio happens to be in a place where, except for the northwest corner, we have very poor wind resource. It's not like West Texas or Wyoming where the wind's blowing hard all the time. So the economics of building wind power generation are not very good here. At the times when we need energy the most, which is the wintertime when we have the big thermal loads from cold weather, the sun doesn't happen to shine very much, right? Mm-hmm. If you've been through a central Ohio winter, it's kind of gray for quite a while during the winter. So solar power doesn't make a whole lot of sense here either. So what are we going to do in places like this? And a lot of people live here, right? Mm-hmm. We just wrote this proposal about PJM service territory, PJM interconnect, kind of the grid for, let's see, what is it? Pennsylvania, New Jersey, Maryland, Ohio, parts of Indiana. I think it reaches to Chicago, actually. But about 1 in 5 or 1 in 6 people live there, and they have similar climates in the United States, and they have similar climates to what we have here. So, California can solve the problem, the energy problem, fairly easily because they got the sun shining all the time. What do we do in our region? There are some things that make a lot of sense here. Combined heat and power makes a lot of sense. So we have abundant natural gas that is going to be around for a while. We might as well use that to the greatest effect that it can be used. So combined heat and power is something where we're kind of capturing the heat that would otherwise be expelled from power generation and using it to heat our buildings. Better insulation and tighter buildings make a lot of sense here. Ohio is kind of the northernmost part of the country where electric heat pumps make sense. They're kind of on the border for the economic case for doing that. But there are technologies that work here. It's just a different mix from other parts of the country, I'd say.
Interesting. You mentioned natural gas with abundant kind of at least a relatively long-term option. Is that with fracking? Is that without fracking? And how, this is another pendulum or another balancing multiple things together, I imagine.
Yeah. So, in a perfect world, we wouldn't need it, of course. Mm-hmm. In reality, we're still getting something like 1 or 2% of our energy from renewable sources. There's large parts of the country where the power generation that's coming online is largely renewable because it makes sense there. We're talking, West Texas, California, places like that. But there's a big portion of the country where natural gas is going to be around for a while. And I think our best option is just to use it as well as we can. So high efficiency power generation along with the capture of the heat for the buildings makes a whole lot of sense. Ohio State's actually building it's like 110 megawatt combined heat and power plant because they did this calculus.
Wow.
And saw that, biggest expense is heating the buildings. And it's a university, so the big energy consumption is during the school year, which happens to be in the wintertime. We need heat and we need power, and the sun's not shining.
Very interesting.
I know you've worked a lot with building sustainability. I'm just kind of curious, what does that term mean to you, and what solid advancements do you see being made in terms of construction sustainability?
Yeah, so that definition of that word is usually pretty nebulous.
Mm-hmm.
I think most people consider it to mean that we can keep doing what we're doing in perpetuity without running out of resources and without kind of harming ourselves. So that's kind of usually captures kind of an all above approach. So again, we often have these competing interests. We talked about the energy and air quality interest. There might be something along the lines of economic interest versus, wanting to generate renewable energy, for example. If we had all the money in the world, we could do that, but that's not the case. So it's just a matter of doing things right, I guess. Not taking shortcuts and things like that. As far as sustainable building practices for homes, again, the best thing we can do is to reduce the amount of energy that is needed at the homes. There's the case for creating energy at your home is pretty weak at this point if you have not already tightened everything up to the point that it's one of the more efficient homes in the country, right? So energy efficiency is always the first, the low-hanging fruit that we should attack first, and it's a big part of the sustainability drive in general.
Interesting. Well, I know I took note that you had worked at Lawrence Berkley and also the National Renewable Energy Lab. It's been a few years, but at one time I had worked some with, I believe it was Dr. Akbari at Lawrence Berkley and some others on research being done into the energy efficiency of roofing materials. Just kind of curious, what areas did you work in at the two national labs, and do you see any impact of what you were working on, happening today?
Yeah. So at LBNL, Lawrence Berkeley Lab, I was focused on the smart ventilation concept. So the pioneers of that concept were Max Sherman and Ian Walker. Max was one of the kind of original gangsters in our field. He wrote a PhD thesis about close to 40 years ago, I guess, where he was just looking at what would constitute like a reasonable kind of science-based way to ventilate our buildings. That's how new the science was that long ago. He's still very active. So the smart ventilation concept is the idea that in commercial buildings right now, and soon to be in residential residences as well, we're just kind of dumping air, and we don't really know. We're not measuring air quality in real time, and we don't know the effect on the occupants. We just know that if we provide about this much of air, people aren't going to complain. They're not going to come down with these sick building syndrome symptoms, et cetera. So the idea is we could do that a little bit in a more smartly, if you will, and that can involve things like knowing that people are there. That's kind of the low-hanging fruit, but it could go all the way up to measuring individual airborne pollutants with these low-cost sensors, and then optimizing a control strategy for your ventilation system and air cleaning system around that. So I've continued to do a lot of work on that, both on the hardware side, where we're looking at hardware needs for reliably measuring the pollutants of concern in indoor environments. And then also on the software side, we can integrate some machine learning, artificial intelligence to predict when high concentration events are going to happen. We can predict when people are going to be happy or not happy based on not just pollutant concentrations, but also the interaction of that with all the thermal variables, temperature, humidity, outdoor temperature, the amount of light, etc., and do things in a smarter way. And hopefully we can save energy at the same time that we're providing a better environment for people to live and work in.
That's interesting. Hearing the OG was only 40 years ago and he's still around. So that's pretty cool, having a conversation about something so new and on the leading edge. But I thought of this question earlier. I'm glad we kind of circled back. This idea of indoor air quality and sick building syndrome. In your experience, have business owners, business leaders on the adoption side of these new technologies, have they been quick to understand the impact of how improving the indoor air quality impacts the productivity and profitability of their business, or have they been slow to change and adapt themselves?
Yeah, that's a really good question. So this has largely been confined to the world of academia and national labs, indoor air quality research. We've been doing a lot of, figuring out what's going on in the last 20, 30 years. I think COVID was the impetus that was needed to get this into the market. Monetizing this is a challenge, especially before COVID. People didn't, both residential homeowners and commercial building owners didn't necessarily see the motivation for changing anything. Their main concerns are, is somebody complaining? Nobody's complaining. Okay, we're good. Or if you're a homeowner, you want things that are going to last, that aren't going to break, that aren't going to cost you a lot of money, sort of thing. Not too many people think about their indoor air quality. I think that's changing for sure because of some of the awareness that researchers have brought to it, but also COVID, and then also the energy efficiency concerns that are causing us to tighten our buildings up are going to drive more people to think about, well, if there's no air getting in and out of our buildings, like what's that mean for what we're breathing and things like that. There is a lot of evidence, however, that there's a financial benefit to be had from improving your indoor environments. Consistently, we see that there's been a bunch of experiments where they either give children tests or they give workers some quantifiable task to do, like I don't know, counting things or something like that, and how many can they do in an hour. And it seems to max out at about a 5% improvement if you change the ventilation rate. You get diminishing returns after a while, but it maxes out about a 5% improvement in productivity. And I think there's a lot of business owners who would love to get 5% more out of their workers, and then it's just the cost benefit analysis for bringing in more air versus getting the extra 5% out of your employees. And again, we're trying to get to the point where we can do both, right? Just through smarter control.
Sure. Yeah, 5% is huge.
Yeah.
Dramatic.
Are there any particular areas you'd like to see changes in building codes or ASHRAE standards in the future, or anything that you're really passionate about?
Yeah, building codes are a big issue. I think it's coming. Like I said, California often paves the way for the rest of the country. The one example I gave, that the worst home you can build is a net zero ready home. That was just one part of the bigger initiative over there that I don't remember the numbers exactly, but the commercial buildings, I think they're saying something like, 50% reduction by 2030 or something like that. So it's coming. I'm a little bit ambivalent about the kind of top-down approach,
Mm-hmm.
There's always unforeseen consequences.
Yeah.
You're going to affect things that you weren't thinking about. The better approach is just doing things that are obviously a win-win-win for everyone. So coming up with a way to provide, for better homes that are more comfortable and healthier, also more energy efficient, that people are kind of like to live in, and then those things will kind of sell themselves. Yeah, that's building codes, big issue.
Interesting. As you look at your students, I know you work with some doctoral students and things. Any particular areas of study or projects you see being taken on by students today that you think are real exciting?
Yeah, so the students that are coming through right now, probably different, I guess, than students 20 years ago. Just about all of them are very excited about changing the world, doing the right thing, being part of little revolution we see happening in the regards to energy and sustainability and things like that. A lot of people are interested in political science and confluence of political science and kind of more technical disciplines. I don't think that was probably the case maybe 20 years ago.
Yeah.
Um, Students are very interested in all the sustainability initiatives. Um, yeah, so the 20-year-old today, they want to improve their world. Maybe 20, 30 years ago, people wanted to make money. I was certainly one of those, but yeah, they're concerned about their environment and the sustainability of their societies and things.
I certainly see that too in younger folks, a lot more concerns for society and overall things. And you're right. We were, when I was growing up, and I have a number of years on you, but, it was more about how do I get out in the world and start earning a living was kind of the driving thing. So if you were to stepping back from your own students, you think about someone in their 20s getting involved in, let's say, the hands-on aspects of construction, perhaps as builders or remodelers. Any advice you'd give to them for them to make sure that they're kind of on the front edge of things and they are going into areas of opportunity?
Yeah, I just say, just like with anything, I mean, do what you do as well as you can, and I think the opportunities will kind of present themselves. I don't think it's a matter necessarily of chasing down what area is hot right now and trying to get into that, but whatever you find yourself doing, do that as well as you can. I have certainly met people who started out as contractors for ductwork and then climb their way up through now have PhDs and they're doing cutting edge research in HVAC and things like that. So just keep doing what you're doing and do it as well as possible, and I think things will open up.
That's good advice. Curious, besides yourself and maybe other colleagues at Ohio State, who are some of the thought leaders in building science today that you think we ought to be paying attention to?
Yep. So there's 6 or 8 university groups that are focused on building science. I don't know if I want to tout the competition on the radio, but yeah, there's the good group at Purdue right now. There's a good group at Berkeley. There's a good group in Texas A&M, and then the program I'm from at University of Texas, University of Colorado is really good at this. And then there's a lot of good work coming out of the national labs. I was part of the commercial building group at National Renewable Energy Lab. They're doing a lot on. They're leading the software development. That's a big thing. We're doing a lot of energy modeling for commercial buildings mainly. The software is about getting to the point where it's usable enough by an average person with an engineering bachelor's, let's say. You don't have to have written the software yourself in order to be able to use it. That we can start modeling a bunch of different design options before we actually do construction on commercial buildings. So NREL is leading that charge. LBNL is a part of that as well. Those are the 2 big centers, I would say. There's a few other things going on in Pacific Northwest National Laboratory and a few other places. But yeah, I'd say those are the big kind of centers of the building science world right now.
Interesting. A lot of brilliant people working on important questions. I'm curious, what is the success right now, and how do the prospects look? What are the challenges about bringing these lab advancements to commercialization and adoption and funding and production, all of those other factors that come into play?
Yeah. So I work mainly in the HVAC industry. And it's kind of a notoriously extremely slow moving industry, right? So basic vapor compression, air conditioning is a technology that was invented over 100 years ago, and it's what we're still using for the most part. There have been some changes where we've made that a little bit, incremental improvements, but it's an extremely slow moving industry. There have been successes. Uh, Things like dedicated outdoor air systems, where we're kind of separating the dehumidification problem from the air quality control problem from the thermal conditioning problem. That's something that came out of Penn State maybe 20 or so years ago, and it just slowly made its way, and it's almost the kind of go-to HVAC strategy for most commercial buildings now. This variable refrigerant flow, that's a big innovation where we're not pumping air around our buildings necessarily anymore. We're pumping refrigerant, so you need less duct work and things like that. And you can also do tighter control on the temperature of the refrigerant, and then get some efficiency from reducing the condenser temperature and things like that. That's a big innovation that, again, took 20 or so years ago. It's mostly out of Japan where that was coming. But yeah, so these things take time. I don't remember what your original question was now. Something about the pace of adoption of new technologies and things. Yeah, this smart ventilation stuff that we're working on. People are starting to put sensors in their homes and things now. You may have a little air quality sensor in your home right now. The point at which most buildings are under smart control, it's going to be a while, matter of decades probably. And you always have the problem where, unlike other industries, you're not going to get it. You might get a new cell phone every couple of years, right? But your building's going to be around for 50 or 100. So, and very few people are willing to dump a bunch of money into their existing home or commercial building to bring it up to the state of the art. They wait until they're going to build a new building, right?
Sure.
So, yep.
Interesting. I'm curious. I mean, this has been really interesting, I think, for our listeners in particular. I loved your advice to younger folks, find what you enjoy doing and doing it, stay current, keep up with things, but go where your passion drives you. And I think that's pretty cool. Anything else we haven't covered today that you'd like to share?
I can't think of anything. Yeah, I've had fun talking. Yeah, it's good to talk with people who are out in the world doing things and not just in the ivory tower with me. So, been good.
Well, great. Well, thank you so much. Tell me, why might anyone want to contact or connect with you, Dr. Clark? And if they wanted to, how could they go about doing that?
Yeah, I'm always eager to collaborate with people, especially builders and building owners who want to push the envelope a little bit. We're always looking for test sites to try things out, especially if you're interested in the smart control or smart air quality control. And if you want to contact me, my email is clark.1217@osu.edu. My research website is the letter u.osu.edu/clark.1217, u.osu.edu/clark.1217.
Great. Well, thank you again so much for spending this time with you. We sure appreciate it, and we really appreciate also our listeners out there tuning into Construction Disruption. I really think you've given us some great insights to go forward on what's going to be driving construction in the future, and some things that I think most of us don't think about every day. So thank you very much for being with us and sharing that with us.
Yep, thanks for having me.
Well, I think that was quite interesting talking to Dr. Clark. And I guess one of the things that kind of really hit home with me was the amount of research and effort being put into air quality and these things. I mean, I knew it was a concern, and every once in a while you hear of sick building syndrome. Every once in a while you hear of a bunch of people gathering together and getting sick. And certainly COVID, did bring that to the forefront, where you started seeing these demos of restaurants and air exchange units and, people getting sick from ventilation. But I guess I just never realized there was that much going into it. And yet at the same time, his comment about how slow that industry, and I think that's been our experience with all construction. That seems to be a real limiting factor in change and making things better, how slow that is.
Yeah, I thought that was really interesting. And my question about sick building syndrome, when I asked it, my reference for it was, I assumed he was going to start talking about mold was growing on the inside of walls, and buildings were breaking down and failing at a more rapid rate. I wasn't thinking about literally the humans in the building getting sick, and heard some about that, but that how prevalent it actually was. And then that was back in the 80s. We're seeing that. We're still slow to adopt. We're still on this 20-year pace of adopting new technologies, when we're looking at our P&Ls and balance sheets and trying to carve out 0.25% here and there for profitability, when there's technology here that he had 8 to 10 institutions, universities that are cranking out new options to improve at 5% levels. That's huge. So what are the barriers to getting that rolled out at a much more rapid rate moving forward?
I guess and I think of the barriers, but then I also think for someone young and getting started, and there's so much ability now that didn't exist when I was coming up, to go out and learn what those hot topics are and what those things are that potentially could really be some significant incremental change. And out of that is where the opportunity comes. As we talked about, he and I kind of joked about how when we were coming out of college, it was all about getting a job and making money. And yet the opportunities are still there. And certainly you can be serving both masters, if we will. I mean, you can be doing things that are good for society and good for buildings and good for health and good for individuals. But yet there's still opportunities in there to make money also. And I think that's kind of exciting for folks that really want to dig into this and say, gee whiz, where can I commercialize things? Where can I monetize things and really take advantage of the technology and where that's leading?
Absolutely. The people diving into it, the current and up and coming generation, opportunity to do well financially, this deep ethos to change the world, plus the perspective that, they do get a new phone every 2 years. Why are we messing around for a lot longer than that to start implementing these things? And hopefully those three things together create a driver machine moving forward.
Yeah. Well, good stuff. This has just been, I think, a really interesting episode of Construction Disruption that I hope our listeners enjoy, and hopefully we can all walk away a little bit inspired with finding those areas where we can serve two purposes: push things forward, make things better, and at the same time find some economic vitality in it all as well.
Absolutely.
Great. Thanks so much, everyone, for joining us. And I encourage our listeners, please watch for future episodes of our podcast. We have more great guests on tap in coming weeks. Until then, I encourage everyone, change the world for someone, make them smile, bring them encouragement, bring them hope. Those are all some of the most powerful things that we can do to go out there and change the world, one interaction with someone else at a time. So again, thank you so much, Dr. Clark. God bless everyone. Take care. And this is Isaiah Industries signing off until the next episode of Construction Disruption.